Right, okay. So maybe I'll just ask you quickly, right? So for question 1, let x be a standard normal random variable, right? Fill in the blanks. There is a what percentage of probability that x exceeds 1.645? So basically you have, anybody wants to say it out loud? Anybody? So your standard normal is centered at 0, right? And the variance is 1, okay? So you have 1.645 here, okay? So the area under the curve will give you the probability, right? So what's this percentage?
Use a table.
Yeah, sure. You can consult the table, right? So anybody? What's this value? This constitutes the area under the curve here is 20%.
0.05.
Sorry? Somebody said
0.05.
0.05, right? Okay, so percentage is 5%, yeah? So, okay, proportion is 0.05, okay? Right, okay? So this one asking for percentage, so please put 5%, right? Not 0.05%. It means 0.05 is correct, but when you say 0.05, then it's not correct if you are using percentage, okay? Just percentage you have to multiply by 100, right? Okay, how about the second one? X lies between what and what with probability 99%. So between here and here, right? This is 0. This is A. This is minus A, okay? So this part here takes up 99%. So what are these two values? Anybody? So this would take up 0.5%, right? Same here, right? So if you check the table, this would be 0.005, right? Okay, so this area here constitutes 0.05. So you can check for the cutoff values here, right? The critical values. This one is just by symmetry, okay? So anybody? Check the statistical tables. Okay. So you could see here, right? So this part here has to be 0.05. So 0.005, right? Okay. So it should be here, right? Oops. Okay. So 0.0. So you look at this diagram here, right? So the part that your alpha here is the probability, right? So 0.005, so the cutoff is 2.5758, okay? So this part here is 2.5758. right? 2.5758. That's about 2.576, all right? Okay, so over here, this should be 2.578. Sorry, 6. Okay, and this one is minus 2.576. All right, okay, clear for everyone?
Yes.
Yes.
Okay, so then the next question is x exceeds what with probability 2.5%? So you have this one. So over here is 0.025, right? Or 2.5%, right? So what is this value? So basically this question is just giving you some exercises on finding cutoffs, right? Critical values. So this value will be quite large, right? What is this value? Anybody?
Should be 1.96.
Okay, great. It should be 1.96, right? If you check the table, it should be 1.96, right? So this is about 2, okay? Actually, if you studied, if you recall the empirical rule, right? Your empirical rule says that plus minus 1 SD from mean will take up about 68%, right? Plus minus 2 SD, 95%, right? And plus minus 3 SD, 99.7%, okay? This is empirical rule. So you look at this one, right? Plus minus 2 standard deviation. So that will be 0. This is a minus 2, right? Because here your mean is 0, right? So here we'll take up 2.5%. 2.5%, okay? So of course here, this is of course more exact, right? 1.96. But roughly it should be close to, I mean, if you know the empirical rule well, then you know that this, without checking the table, you know that it's something roughly 2, okay? Right, okay, so that's great. Let me clear this. Okay, then we can go to the other questions, right? So I've got requests for question 4. Okay. So before that, maybe I also make sure that everybody knows how to do calculate normal probabilities. Okay, so for example, in question 2, right? So this is actually just a practice question, right? So your x is normal with mean 110 and the variance is 144. Okay. So find the following probabilities. Okay, so P of x larger than 107. Okay. So this one, first thing is you normalize it, right? So you normalize by subtraction of the mean. Okay. The mean is 110, right? You subtract 110, you divide by the standard deviation, right? Square root of 144, okay? So this will be your Z random variable, okay? So the Z is always you subtract the mean, the population mean, and divide by the population standard deviation, okay? So you subtract and divide on the left, you do the same on the right, right? Okay, whatever you do on the left, you do on the right to balance out. Okay, so here you have PZ greater than minus 3 over 12, right? So that's Z minus 1 over 4, okay? Right, so your Z is standard normal, so that allows you to use the standard normal table, okay? So this is 0, okay? So you want, so minus 1 over 4, right, is minus 0.25, okay? So you want the area under the curve here, right? You want this piece, right? So how do you find this piece?
1 minus 0.25, the positive value.
Okay, great. Please remember to use the symmetry property, right? Okay, so in order to find this piece, right, you take 1, subtract this, you take 1 and subtract this piece, okay? All right. So what will that be? So this piece is actually the same as symmetrically. So this piece here is the same as this piece, right? By reflection, okay? Right. So basically, the piece that you want here is the same as this piece.
The closest value you can get is 0.2533 for Z on the table.
Yeah, sure. So basically you can, this is P, Z greater than 1 over 4, right? Okay. So 1 subtract this piece here will give you this large piece, right? So over here you can find it from the table, right? Because the table will give you the right tail. Okay, the Murdoch and Barnes, the red statistical table will give you the right tail, whereas some statistical tables will give you the left tail, right? So to make the discussion simple, we just follow Murdoch and Barnes table. But actually, once you understand this concept, you can use any tables, okay? All right. So then move on to the next one. The next one is you have, so maybe I just do the one with the interval, right? Between 90 and 120, okay? So you want to find x between 90 and 120, okay? So again, same, you do the normalization, right? So x subtract 110 over square root of 144. So do the same on the left-hand side and the right-hand side, okay? So basically this leaves you with, that's 10 over 12. That's minus 10, minus 20 over 12, okay? So that will give you 5 over 6, and this will give you 3 over
5 over 2.
So 5 over 3, okay. Right, so then your sketch will be like, always try to make a sketch, right? So that you won't get it wrong. If you do a sketch, you will not miss it, right? Because the calculation is basically just a simple geometry here. Most of the time, we notice that students make mistakes because they try to move this symbolically, right? It's better that you make a sketch, okay, to protect yourself from making small mistakes. Okay, so you basically want this piece, right? The piece between these two. So basically, that's the same as getting 1, subtract this piece here, right? And then you subtract this piece, and then you subtract this piece, right? Okay, so you can write this as 1. Once you understand the idea, you can write it as 1 subtract p z greater than 5 over 6. And this piece here is the same as z greater than 5 over 3. Okay, so you can ignore the minus sign because this piece here by symmetry, it would be, I think this is larger, right? Because divide by 3, so it'll be 5 over 3 here, right? Okay. This piece is the same as this piece, okay? So we can write it like this, and these two values, you check it from the table, you should be able to find, right? Okay, so basically this is actually quite straightforward. I hope everyone can do this, yeah, because this kind of calculations is sure to come out. Okay, so and there's no difficulty if you can do the normalization, right? Here's the normalization. Okay, subtraction of the mean and division by the standard deviation. After that, you get the standard normal, random variable that allows you to check the standard normal table. Okay, and once that, remember to sketch. Okay, all right. Whatever probability statement that you want, sketch it so that you know what is the geometry that you want, and then you can accordingly use subtraction or some suitable ways to find it. Okay, right? Make sure you know how to do this, right? Because this is coming out all the time. Okay, so it'll be a pity if you are not able to get it right. Okay, so all right, okay, make sure everybody knows this, yeah. Okay, so this Zoom here, it only gives me it only allows me 40 minutes, so I started a bit earlier. So now I only have about 3 minutes left. So I have to close the session and then send you another link, okay? Then you'll come back again, right? Then we'll continue with questions 4, 6, and 8, all right? Okay. All right, okay. So question 4. So you have the amount of time taken by a bank teller to serve randomly arriving customers has a normal distribution with mean 2 minutes and standard deviations of 30 seconds, right? Okay, for 2 of the customers, what's the probability that both of them are served in 1 minute or less? Okay. So basically the serving time, right? So your serving time, right, is let's say you call it X, right? So your serving time X is normally distributed with a mean of 2 minutes. Okay. And a standard deviation of 30 seconds, right? 30 seconds, you have to convert it to
0.5.
So your standard deviation here is 30 seconds. So that's half a minute, right? Okay, that's half a minute, right? So sometimes this standard deviation is half a minute, which is the same as the variance is 1/4, right? Okay. So then once you have that, you can answer the questions, right? For towards the customers, what's the probability that both of them are served in 1 minute or less, right? So customer one, right? Customer one, the serving time is less than 1 minute, okay? 1 minute or less. So again, you normalize, right? Subtract 2, divide by standard deviation, right? 1/2, okay? So you do the same. So that's your Z. That's then equals to minus 2, right? So this should be, if you know your empirical rule well, this should be, okay, it's this side, right? This should be about 0.05, right? Sorry, 0.025. Okay. All right. So the other customer is also the same, right? Because they are independent, right? Both of them are served, right? So the other customer, you also have the same situation, okay? So you want both of them to be below, serving time below one minute. So you just multiply, right? Okay. And then if 4 customers are served, what's the probability that at least one of them have serving time that exceeds 2.5 minutes? Okay. Okay, so now again your serving time. Let me just write it down. This is okay. Probability that at least one of them have serving time that exceeds 2.5 minutes. Okay, so serving time exceeds 2.5 minutes, right? So this is the event. This is the event that serving time exceeds 5 minutes, right? 2.5 minutes. Okay. So this one is you subtract the mean, divide by the standard deviation. Okay. So do the same. So this will be 0.5 as 1/2. Okay. So 2 so is 1, right? Right. So this is the serving time exceeding 2.5. So when you calculate, right? So you have this part here, right? So you can check the table. If you check the table, what should this be? So let me check the table a bit. One. That would be 0.1587, okay? It's be 0.1587, okay? From the statistical tables, right? Now, you got 4 people now, right? So it says, what's the chance that at least one of them, right, has x greater than 2.5. Now, in this case, this event here, right, at least one of them is having x greater than 2.5. This is actually, instead of looking at this, you can look at the complementary event, right? So take 1, subtract p of none, right? None have x greater than 2.5, okay? This is at least one, right? So the complementary is no one has x greater than 2.5. Okay. So if you use the complementary event here, then this probability is easy to calculate, right? So none have x greater than 2.5 means all of them are below 2.5, right? So z below this, okay, raised to the power of 4, right? Okay, this pz of greater than 1 is serving time exceeding 2.5. So if none have this, that means it's the other way around, right? So you have this. So this should be 0.8413, okay? And then since there are 4 people, right? So they are all occurring independently. So we'll just multiply them together, okay? So you should get something here, right? Okay, is that clear to you?
Yes.
Yes, doctor.
Okay, if you check the solution, since you are using 2, right? So it's it's not exactly 0.025, right? It's something like 0.02275, okay? But you get the idea, okay? So, right? So this one should be 0. So the answer for this should be, if you check the solution later, should be about 0.499. Okay. All right. Okay. So then I'm going to go to question 6. Okay. So question 6, you have a Poisson distribution for modeling the number of mutations in the banana plant, right? So let me get the question. Okay. So we have this is how they actually generate mutations, new varieties for crops, right? They sometimes use irradiation, okay? So they irradiate the plant to introduce new genetic variants. Of course, most of these variants are harmful, so that's why they do large amount and then they select, right? They do culturing and then they select by chance. Some of these mutations actually produce some desirable traits. So then they select this and then they create a variety, right? So this is how they actually, in crop science, is how they generate new varieties for commercial purposes. Okay, if you wait for nature to happen, that takes too much time, right? Okay, so that's why this gamma irradiation is some kind of accelerated acceleration of the introduction of new variation, okay, in the population. Right? Okay, anyway, so on average, they generate an average of 256 mutations, right? So you let your X be the number of mutations, right? And we know that X here follows the Poisson. Now, why do you might ask why do I directly use Poisson? Now, first thing is this mutation, right? The mutations are actually rare events, okay? So Poisson model is good for modeling rare events like accidents, okay, radioactive emission, right? And as long as the thing that happens has can be considered as a rare event, right? So then Poisson model is usually suitable, okay? So mutations are rare, all right? So then you can use Poisson, right? So the mean, Poisson mean is 256, okay? And then you want to find the probability that X has less than 220 mutations, okay? So that means this is, X is 219, right? Okay. Now, how are you going to do this? Of course, if you can use the table directly, it's fine, right? But over here, you are not able to use the table because your Poisson mean, you don't have coverage until that, right? So basically, then you have to do some kind of normal approximation, okay? Use a normal approximation, right? And then you have to apply the continuity correction, okay? So once you have this, right? So if you apply this will be less. So after here, you apply the normal approximation, right? So that would give you subtract the mean, right? And divide by the standard deviation, right, of the Poisson is the same as the square root of the mean, right? Now here you have to use what should you use? Should use 219.5. Okay. I'll explain it a bit why the 0.5 actually comes out. Okay. This is this square root of that is 16. Okay. So you will get Z. So this one here, you will get something like minus 2.28. Okay. Right. So basically, you want this part here. So this is the same as Z greater than 2.28, right? Okay, this piece here is the same as this piece, right? They are the same. So you can check the table, right? And I leave this to you. Okay. Now you might be curious why you have a 0.5 here coming out for continuity correction. Okay, this actually comes from a this is basically just a geometric consequence. I'll show you why. Okay, so basically when you do a continuity you use a normal approximation, right? So for example, suppose you have some discrete probabilities like this, okay? So these are the rectangular bars, right? Okay, and suppose your normal approximation works on them quite well. So this is maybe like, say, this is 2, 3, 4, 5, right? So the height here represents probability, okay? Right, the base here is of 1 unit, right? So if you fit a normal curve on them, right? If the normal approximation works well on that, it will look like this, okay? The curve will generally pass through the midpoint, right? Of this rectangular bars, right? Okay. Now, if you want to calculate this probability, for example, you want to calculate probability of X equals to 4, right? Okay, so it's basically this bar, right? Now, if you use a normal approximation, okay, that means you want to use this red curve here, right? So how would you do it? So basically, you look carefully, right? So this is the normal approximation, right? Okay. So, well, let me write that down more clearly. Okay. Okay, so if you use the normal approximation, it's basically this rate curve, right? Now you watch carefully. If you take this rate curve, if you do the integral, right? Like the area under the curve for the red one, what do you see here? It's this piece, right? Okay, the area under the curve for the this red line from here to here will give you this piece, right? Okay, now you watch carefully. This integral is going from 3.5 to 4.5, right? It's in between 4 and 5, okay? And the base is of length 1. Now, watch this carefully. This piece here of the rectangular bar can be cut, rotated, and then fitted here. Okay, it's not exact fit, but almost the same, right? Approximately. So basically, so that's why your P of x equals to 4, which is this rectangular bar, is basically the same as this integral going from 3.5 to 4.5. Okay, that's why you have a continuity correction of 4.5 on the upper side and the 3.5 on the lower side. Okay, right? So is that clear to you?
Yes, doctor.
The 0.5 actually comes because you are basically rearranging, right? You are rearranging the area, okay? And it happens that the part where you have over, right? Over the red, you can rearrange it to the part where you have less for the red, okay? So it fits actually quite well. And this is over the interval of 0.5, right? So this explains why you have your continuity correction done like that. So basically what happens is that if you have an equality here, right? Okay, so then the upper part will be you add 0.5, okay? The lower part you have to subtract 0.5, okay? That's all to it. It's actually, once you understand the geometry, basically this is not a mystery, okay? It only is a mystery if it's just given as a recipe without some explanation about the geometry, okay? Right, okay, so I hope you will do continuity corrections with confidence, all right? This is really quite not that hard actually, okay? And then 6 is done, so the rest you can do, right? Okay, the rest are just further exercises, right? So you follow that idea and then continue, okay? Right, and then so we almost up for time. Okay, so number 8. So this is the question requested for discussion, right? So you have some kind of measurement of speed of cars, right? Okay, and you're asked to solve some of these things, right? For example, suppose the speed of individual motomobiles are normally distributed with mean 88 kilometers per hour. Okay, if 10% of the automobiles travel faster than 110, okay, find those things. So basically, those are kind of like some kind of back calculation stuff. Okay, let me just clear this first. So, okay, now here the information given is, let's say x is the speed of automobiles, right? Okay, so your x is normally distributed with mean 88, but the variance is not given, right? But we just note it down like this, right? But what you know is that 10% of the automobiles travel faster than 110, which means from the statement, right, you can construct this information, okay? Probably that x greater than or equals to, so greater than 110 is 0.1, right? So 10% of them, right? So from here, actually, you can recover the standard deviation by normalization, right? So this information here, if you normalize, you will get this, right? So this will be 110 minus 88 divided by sigma, okay? Equals to 0.1. Basically, this is your Z greater than 22 over sigma equals to 0.1, right? So you sketch a curve. So this is your 0.1, right? So this has to be on the right hand side because your probability is only 0.1. This is 22 over sigma, okay? So you can check the statistical table. What is this value here? What is this critical value? Okay, that gives you a 0.1 area here. So if you go to the statistical table, right? Let me share. Okay, so we are at the page of the statistical table. All right. So you could basically look at table 4, right? You want your alpha to be 10%, that's 0.1. So you look for here, 10% is 0.1. So it's over here, right? Okay, 1.2816. Okay. So it's over here, 1.2816. Right. So basically, you know that your 22. Now you know that your 22 over sigma is 1.2816. Therefore, your sigma can be recovered. Okay. Right. So that allows you to work out the what sigma is. Okay. Is that clear?
Yes, doctor.
Okay, great. Then B, percentage of automobiles travel slower than that. This is trivial, right? Once you know your sigma, then you can then this just becomes a routine question on, okay, so basically you have percentage of cars. So P X minutes. Slower than 60, right? So slower than 60. Oops. So this is so again, X subtract 88 divided by standard deviation, which you already found, right? Which is this guy here, okay? So I just put a star here. So you just plug in, right? Because you already found that value. And less than this, okay? So this is just basically standard question, all right? And then you can calculate, okay? That's easy. Last one, the 95th percentile of the speeds. Okay. So the 95th percentile is basically like this. So you want to find the 90, so P 0.95, okay? So So this is your P 0.95. Okay, this is your 95th percentile. Because on the left-hand side, percentile means whatever towards the left-hand side of this value constitutes 95%, right, of the data. And here is 5%, right? Okay, basically you are trying to find the cutoff here, right? Okay, so basically you want to find your P 0.95 is basically the same as P. Okay, so basically it's like this. So is this cutoff, right? Okay, so P X less than this cutoff, right? Let's say I write it as A, okay? Is equal to 0.95, all right? Then you just work back, just normalize 88 over the standard deviation, right? So this one just now calculated. So A minus 88 over this is 0.95, right? Okay. So then you have to, when you look for the table, right? The table 4. Okay, so your A minus 88 over this value will be equal to, so this is 0.95 on the left, but the table gives you on the right. So you have to look for the 5%, right? So over the 5%, let's look at the table. Okay, new share, table. Okay. So look at 5%, it will be here, right? 1.6449. Okay, 1.6449. So let's go back to the whiteboard. So this will be 1.645. Okay, 449 is 45, right? So then you can solve for your A. Okay. By simple algebra, okay? Multiply with the known standard deviation and add 88. All right, okay? So I hope that has been clear, right? The explanation. Right, okay, so I think it's just about time, right? I think you probably have another class to go to. Okay, so are there further questions from everyone?
All right, that's it. Thank you.
Okay, right, sure, okay. See everyone later, all right. So I'll end the meeting now, yeah?
Thank you, Doctor.